Hello Year 9, welcome back to another episode of Science with Miss Clark in lockdown. Today we are going to be doing a prac that has to do with the conservation of mass. So last week we started talking about some of the laws of how we have to conserve mass and atoms and energy. So this prac will be showing how we can put into practice the idea that the law of conservation of mass suggests that during a chemical reaction, mass cannot be created or destroyed. So the mass has to remain. So we're going to do a prac, or I'm going to do the prac. You're going to watch it. What you need to do is get page 84 of the textbook up. You need to copy this table into your book. As I go, I will show you what the numbers are, and I want you to fill them in this table, okay? So I'm going to follow this method here. You can follow along with me. Open up to page 84 so you can see that. So the beauty of having a video is you can pause it. So you can pause it now, go and copy that table into your book so you are ready to write down the results. So what I have here in terms of my equipment, I have 4 250ml beakers. I have my electronic balance so I can weigh it. That's such an unflattering angle. And I have 4 different chemicals. I have copper sulfate, sodium bicarbonate, sodium hydroxide, and ammonia. Okay, so I am going to use 50 mils of these substances, and I'm going to show you what their masses are before, and then we're going to combine them and we're going to see what the mass is. So I'm going to start, I'm up to step 2 because you've already copied your table. I'm going to pour copper sulfate solution into one of the beakers until it reaches 50 mils, and I'm going to label that blue. So I'm going to do that now. So I'm going to use this beaker multiple times throughout the prac. So I'm going to pour copper sulfate in. I should pull up my lab coat and put my hair back. Can you tell it's been a while since we've done pracs with chemicals? All right, so I'm going to pour 50 mils in to our beaker. Alright. So, as you can see, I don't know if you can see it. Anyway, there's about 50 mils in there. And I've labelled that blue. Next one, I'm going to add 50 mils of sodium hydroxide. Should have tried to make sure I can open it before I start filming. It's fine, it's just like when we're in the lab and I can't open some of the bottles. Alright. So there's 50 mils of the sodium hydroxide. So what I need to do now, I'm also going to place both the beakers on the electronic balance and determine their total mass. So I'm going to record that. Well, you're going to record it in the table. I'm not going to write it down. So I've tared my electronic balance. So you can see they're both on here. I don't know if you can see that. It's in grams. We've got 280.5 grams with these 2 beakers. So what I'm going to do now, you need to write down that number in the first row where it's total mass before mixing in grams for sodium hydroxide and copper sulfate. Up to step 5, so carefully pour the copper sulfate into the sodium hydroxide and observe what happens. So hopefully you can see this. Look at that. So What we're going to do now is I'm going to put this beaker back on so we can weigh it. So still got 2 beakers, still got the same volume of solution, and we're going to check our balance. Hopefully you can see that. 208. Well, that's not what it says, so I can't read upside down. 280.5. Let me just read it up the right way, because I really can't read numbers upside down. So we can see that the mass has been conserved, even though we can see that this reaction has taken place. Okay, so I'm going to put that to the side. I'm going to reuse my blue beaker, because I'm going to put some more copper sulfate into that. I don't know if your For You page on TikTok is also full of that girl, I think her name's Emily, who is making salmon and rice. Every time I bend down to look at the camera, I think that I'm her. So thank you for letting me live my my TikTok dreams through teaching you science. I feel like this is even more exciting than salmon and rice, but you know, salmon and rice is also pretty good. Okay, so we've got our copper sulfate in here. The next one that I am going to put in is sodium carbonate. Again, I cannot open that. Drop a bottle. And I'm going to do another 50 mils of that. I am going to weigh them together so we can get the before mass. So what's that? 288.1 grams. So that needs to go in your before total mass before mixing in grams. And again, I'm going to pour my copper sulfate into the sodium carbonate, and you need to observe what happens. You can see that. So we're getting a precipitate forming there. It's quite cloudy. Put that one off to the side as well. Oh, hang on. I need to weigh them. You get my my train of thought commentary as well as we do this. I'm going to weigh it. 288.1. It's the same. The mass has been conserved, which is excellent. Oops. Try not to drop my phone. Now I'm going to put that one to the side, and again I'm going to fill up this beaker again with more copper sulfate. What are the chances that I can open this one? I can actually do it. Amazing. So more copper sulfate. And this is my last clean beaker, and I'm going to put ammonia into this one. Just find it. Another 50 mils of that. So I'm going to weigh that on my electronic balance, and you need to record a mass of 276.1 grams. I'm going to pour my copper sulfate into the ammonia. You need to observe what happens. I don't know why I keep putting it over there. So again, we've got a color change, and it's gone quite cloudy again. I'm going to re-weigh them. They're both my beakers and a solution. What have we got? 276.1. So again, about the same. So write your observation and those masses there as well. Where am I up to? I think I'm done. So I hope you enjoyed that installation of whatever I'm calling this channel. Please like and subscribe. Make sure after you complete your table, you do the review questions. Can I flip this around? Get my double chin. So you need to do these 4 review questions after you've completed your table. So what evidence is there that shows a chemical reaction took place once the solutions were mixed? So have a look at your observation column for that. Compare the total masses before and after, state the law of conservation of mass, and assess whether or not your results support this law. So you're going to need to compare these 2 columns to see if they match up. Thanks for watching. Enjoy my next video.